Alright, what's up guys? We got 809 expressive words for this video. You already know the drill, 15 minutes on the clock. Let's begin. Sometimes people repeat letters to represent extra feeling. Sure. And these strings like groups of adjacent letters are all the same. Yep. You're given a string S and array of query string words. To run word is stretchy. Characters C. Add some number of characters C to the group so the size of the group is 3 or more. Okay. Okay. So interesting. What if I had two of the same words? Like, what if word 1 was like A, B, 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 and then word 2 was like the word in my queries was like, you know, A, B, B, B. So they're the same here, right? Is this word stretchy? I don't think so, because I don't think we're just comparing direct equality. I think we're just, I don't think we include direct equality. We want to see this property where we have to add some extra characters to get the stretchy S, or to stretch out our word and achieve S. Okay. You know, this is pretty interesting. I'm not sure how to do this, well, I'm not sure if there's like some technique to do this. We might have to just like brute force the implementation. I mean, the constraints are pretty low, so it seems like a brute force solution might just work here. It's probably just implementation heavy. There's not really some technique we gotta use. Alright, I guess just like thinking, how can we do this? Okay, I have an idea. I have an idea. I'm going to have a helper function here, and this is going to help us get like the character we're observing and how many instances there are at our current index in any string. So let's do like get count from I. It's a nice long name. So we'll give our index, well, we want to give our string S and our index I. And what we're going to do is count is 0, and while sorry, let me think for a sec. Yeah. So char is S at I, and then while S of I is char, we're going to count plus equals 1, and then I plus equals 1. We're using the parameter, a little odd, but it's okay. And we're going to also make sure I is not going out of bounds here. And then we want to return I. So this is going to get our count, and this will be helpful for us. So we want to return the number of stretchy words. So we're going to start off with 0, and we'll return this later. And we need to just go through each word, right? So for word and words. And now we need like a stretchy test. So I think like stretch should be false first. And then what we should do is okay, we're going to need two indices here. We're going to need I and J to start at 0, and I is going to go through our string s, and j is going to go through our word, and we'll do while I is less than length of wow, I can't speak. Yeah, you see what I wrote though. And j is less than the length of word. Then we're going to do something. And we're going to do something here. Okay. So the first thing we want to check here is if this should be s of I is not equal to word at j. Let's just break out of this loop. We know it's not going to be a stretchy representation of our word. It's impossible. And so after this loop, we're going to do if stretch, then we'll res plus equals 1. And actually, we should have two flags here. This is kind of weird. So if stretch and valid. It's possibly stretched, but we end up not having a valid word. But it's also possible we have a valid word, but we never stretched. So if si is not equal to word, then valid is false. Otherwise, we'll get I count is equal to, what's our long helper function name? So we have si, and then we have j count is self dot this word at j, and all right. So we have if I count is greater than or equal to 3. That's a stretch case. Otherwise, or it's possibly a stretch case. Otherwise, what? Wait, actually, I'm sorry. This should be if j count, because we're trying to stretch j, right? We're trying to stretch our word to fit s. So this is actually if j count is and it can stretch. What's the rule again? It has to be less than 3 characters, right? Wait. Let me think. No, I think I was right before. So if our I count is greater than or equal to 3, then that means we could potentially stretch our j. But otherwise, if the I count is less than 3, then if I count is not equal to j count, I think we just or not return, but we do valid is false when we break. And valid should start true, actually. Okay, now, here's the other case. This is the interesting one. Oh, sorry. However, if I count and j count do equal each other, then we will I count plus equals, no, I plus equals I count, j plus equals j count. Oh wow, this is getting long. And after all of this, if I is equal to the length of s and j is equal to the length, sorry, we should do if valid and I is equal to the length of s and j is equal to the length of word, then so really it should be so if it's valid and this here is not true, then valid should actually be false now. That means we didn't get to the end of both words at the same time. So the groups didn't align. So the validity should be false. Okay, now you gotta consider this case here again. So if our our current group that we're observing in S has a length greater than or equal to 3. That means we could stretch I potentially, or stretch J potentially. Okay. Oh. Oh, this is simple. So if the I count is greater than or equal to 3, if J count is less than or equal to I count, okay, so actually this should be if J count is greater than, then valid is false, and we should break. Otherwise, if J count is strictly less than our I count, that means we stretch. So stretch now becomes true. So we stretched once, right? So our stretch is now true. And then at the end of this, we want to I think here we can just do that, because either way we're going to want to increment our pointers. Right. So a lot of like flags and conditionals, but let's see. 2 positional arguments. I didn't define self. Okay. I'll put 0. How should we look at this? Let's print the word, the I count, and the J count. Sorry, let's print the word as well as SI, so that the current character we should be observing. So, okay, so in this case we're comparing hello to hello. And first we're comparing H, and they both just have a count of 1. Next we're comparing the E group, so the E's are equal, which is good. Oh. Okay, something's wrong with my math here. How am I counting 4 E's? And I'm counting only 1 H? I honestly don't know. Let's print I'm blanking here. Printing a lot of things now, but let's just see if we can figure this out. So somehow we're counting 4 E's. Okay, let's go through hello here. What are our inputs to this function? We're going to be passing in S, which is hello, and I is 1, right? So count is 0, char is E, while 1 is less than the length of S, and E is equal to E. Then count plus equals 1, so we have 1 count, and now we're at I plus equals 2, we're at I equals 2 now. I equals 2, 0, 1, 2. Yep. So this should become 3, and then I becomes 3. And then the count should be 2 right now. And then we add one more. And then I becomes 4, and the count should be 3. Really don't know. So here's what I can do also. I can just click comment all this out real quick and just get like values self dot get count from I, and this is what? This is S and 1. So this should print 4. Alright, how? How is this 4? Am I like reusing variables somewhere or something? I count SI. I is 1, it's 0, 2 is 1, 3 is 2. Oh, I'm returning I instead of count. Oops. Jeez. Oh, jeez, is this slow? Oh, I'm printing every time. Is that it? Oh yeah, okay, that was it. Oh, that was pretty rough. That was pretty rough. Powered through it, but that was pretty rough. Yeah, I don't know. I don't like that too much. Run length encoding. Oh, like, yeah, I've done this in a problem before. I didn't even consider this though. Is this like, I mean, this is like kind of what I was doing, right? I mean, I wasn't generating like the actual run length encoding, but I mean, yeah. Honestly, this is like essentially what I was doing, right? So what would the time complexity of this be? Let me think. Well, we're going for word and words. All right, let's say like n is words dot length, and m is length of s. Well, all these words are 100 length. Sorry, I'm switching it up. This is the length of the words list now. These are the actual words. So, okay, according to this, so this loop would go m times. This while loop, however, I'm getting the counts, but every time I get the count, I am moving up in the index. I think that, yeah, I think that this while loop in combination with this I count or get count from I function for the word s and the word word, I think the combination of this is going to be at worst case what? We do this loop here and this loop here, and together they work to increment I and j up to the max length of the word, and then we end up like down here where like I and j are equal to the length of the words. And at worst case they're incrementing by 1, so that would be, I think this entire loop is O of the max length of actual words. And then this outer for loop is going to be just m length of words. And so this will give us an overall time complexity of m times n here. And what's our space complexity? I think it's constant space. We're just storing integers, right? Like integers and chars. So constant space complexity. And the editorial, however, was like O of k. K is max length of a word. Oh, okay, cool. So they're using like pretty much the same dimensions as I was. But our space complexity is better. They got O of k. We're just using O of 1. But yeah, I don't know. This was a little rough. You only need this amount of words. Well, good for them. Good for them. But yeah, thank you for watching. I'm sorry this was a little rough. My explanation was probably not the greatest as I was going through it. But that's why I'm doing these, so I can get better at doing this. And also you saw me get humbled a little bit, so hopefully, yeah, boost your ego a bit if you didn't struggle on this problem as much as I did. Anyways, thank you for watching. Bye-bye.